requirement for non-metallic sheath cable, often referred to as NM cable, to be installed in accordance with Section 334.12(a)(1) of the National Electrical Code, or NEC, was initially introduced in the 1999 NEC. Therefore, it was not a new requirement in the 2002 edition of the NEC. The primary reason for this requirement is to mitigate concerns regarding the potential for damage to NN cable when it is installed in suspended ceilings within non-residential structures. NM cable, compared to other wiring methods like conduit or armored cable, possesses less mechanical robustness. Consequently, it is more susceptible to damage if not installed correctly and adequately protected. Firstly, the physical characteristics of NN cable make it vulnerable in environments where it may be subject to physical stress or abrasion. Secondly, suspended ceilings can unfortunately become havens for rodents and other pests. These creatures can gnaw on or otherwise compromise the integrity of the NM cable's insulation and conductors. Thirdly, improperly installed NM cable can sag or droop within the ceiling space, increasing the likelihood of it being snagged or damaged during maintenance or other activities conducted above the ceiling. The NEC, a comprehensive set of standards for electrical installations, addresses the safe installation of electrical wiring and equipment. Article 334 specifically addresses non-metallic sheath cable, types NM, NMC, and NMS. Section 334.12 outlines the permissible and impermissible uses of NM cable. The prohibition of NM cable in suspended ceilings in specific occupancy types, typically non-residential or commercial buildings, is detailed within the section. The specific language within 334.12(a)(1) clarifies the environments where NM cable is not permitted. The NEC aims to minimize the risk of electrical hazards. The prohibition of NM cable in suspended ceilings in certain buildings is a direct measure to prevent electrical fires and other dangerous situations. Damage to NM cable can lead to short circuits, ground faults, and arcing, all of which are potential ignition sources. The NEC mandates the use of more robust wiring methods in these environments. Options like electrical metallic tubing, or rigid metal conduit, or RNC, or armored cable, or AC, provide superior physical protection for conductors. These wiring methods are better suited to withstand the conditions typically found in suspended ceiling spaces. Proper support and securement of wiring is crucial, regardless of the wiring method used. The NEC provides detailed guidelines on how to properly support and secure cables and raceways to ensure they are not subject to undue stress or strain. Regular inspection and maintenance of electrical systems are essential for identifying and addressing potential problems before they escalate into hazardous situations. This includes inspecting wiring in suspended ceilings for any signs of damage or deterioration. The requirements of 334.12(a)(1) serve as a reminder of the importance of selecting the appropriate wiring method for the specific application and environment. Factors such as the occupancy type, potential for physical damage, and presence of pests should all be considered when choosing a wiring method. The local authority having jurisdiction, or OJ, has the final say in interpreting and enforcing the NEC. It is essential to consult with the AHJ to ensure that all electrical installations comply with the code requirements in the specific location. Understanding the background and reasoning behind code requirements enhances the electrician's ability to make informed decisions and perform safe and compliant installations. The prohibition of NM cable in suspended ceilings is rooted in the goal of enhancing electrical safety and preventing potential hazards. The NEC undergoes revisions and updates periodically to reflect changes in technology, installation practices, and safety concerns. Staying current with the latest edition of the NEC is crucial for all electrical professionals. Continuing education courses, industry publications, and online resources can help electricians stay informed about code changes and best practices. Proper training and certification are essential for electricians to demonstrate their competence and knowledge of electrical codes and safety standards. Certification programs often require passing an exam and completing continuing education to maintain certification. The NEC is not intended to be a design manual, but rather a set of minimum safety standards. Electrical designers and engineers should consider factors beyond the NEC requirements to ensure that the electrical system meets the specific needs of the building and its occupants. The NEC provides tables and guidelines for determining the appropriate size of conductors for different applications. Correct conductor sizing is essential for preventing overheating and ensuring the safe and efficient operation of electrical equipment. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the requirements for overcurrent protection based on the ampacity of the conductors and the characteristics of the equipment being protected. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and de-energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, minimizing the risk of electric shock. Electrical equipment must be listed or labeled by a recognized testing laboratory to ensure that it meets safety standards. The listing or labeling indicates that the equipment has been tested and found to be safe for its intended use. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes properly supporting and securing cables, making connections in approved junction boxes, and labeling circuits clearly. The use of appropriate tools and equipment is essential for performing electrical work safely and efficiently. This includes using insulated tools when working on energized circuits and wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Lockout-tagout procedures are used to de-energize electrical equipment before performing maintenance or repairs. This helps to prevent accidental energization and electric shock. Electrical safety audits can help identify potential hazards and ensure that electrical systems are in compliance with the NEC and other applicable standards. These audits are typically performed by qualified electrical professionals. Electrical safety programs are designed to promote a culture of safety in the workplace. These programs typically include training, hazard assessments, and regular safety meetings. Electrical safety is a shared responsibility. Everyone who works with or around electricity should be aware of the potential hazards and take steps to prevent accidents. The NEC is a living document that is constantly evolving to address new technologies, installation practices, and safety concerns. It is essential for electrical professionals to stay informed about the latest changes to the code and to apply them in their work. The NEC is a valuable resource for electrical professionals, providing guidance on the safe and compliant installation of electrical systems. By following the NEC requirements and best practices, electricians can help to ensure the safety of people and property. The prohibition of NM cable and suspended ceilings in non-residential buildings is just one example of the many safety measures included in the NEC. These measures are designed to protect people from electrical shock, fire, and other hazards. Electrical safety is a complex and multifaceted issue. There is no single solution that will eliminate all electrical hazards. However, by following the NEC requirements, using safe work practices, and staying informed about the latest safety information, we can all help to reduce the risk of electrical accidents. The NEC is not a substitute for good judgment. Electrical professionals should always use their knowledge and experience to make informed decisions about electrical safety. If you are unsure about how to perform a particular electrical task safely, consult with a qualified electrical professional. Electrical work can be dangerous. Only qualified and trained individuals should perform electrical work. If you are not qualified, do not attempt to perform electrical work. Contact a licensed electrician to perform the work for you. Electrical safety is everyone's responsibility. By working together, we can create a safer environment for ourselves and others. The NEC is a valuable tool for promoting electrical safety. By understanding and following the NEC requirements, we can all help to prevent electrical accidents. NM cable is typically suitable for residential applications. However, it's restricted in specific non-residential settings due to the inherent risks. The code prioritizes safety based on the environment and potential hazards. In commercial buildings, more robust wiring methods are often necessary. This is because these buildings tend to have more complex electrical systems. They also have higher occupancy and increased potential for damage. The NEC aims to minimize risks by specifying appropriate wiring methods. Different wiring methods offer varying degrees of protection. NM cable is cost-effective and relatively easy to install in residential settings. However, its vulnerability to physical damage and pest intrusion makes it less suitable for commercial environments. Conduit systems, such as EMT and RMC, provide a robust barrier against physical damage. They also offer better protection against moisture and corrosion. Armored cable offers a flexible yet durable alternative. It features a metallic sheath that protects the conductors. The selection of wiring methods should always comply with the NEC. It should also consider the specific requirements of the installation. Factors such as voltage levels, ambient temperature, and the presence of corrosive substances can all influence the choice of wiring method. The authority having jurisdiction, or OJ, plays a crucial role. They ensure compliance with the NEC. They can also provide interpretations and clarifications on code requirements. Electrical inspectors verify that installations meet the minimum safety standards. They help to prevent unsafe conditions and potential hazards. Electrical contractors are responsible for ensuring that their employees are properly trained. This includes understanding the NEC. It also encompasses safe work practices. Regular safety meetings and training sessions can help to reinforce safety principles. They promote a culture of safety in the job site. The prohibition of NM cable in suspended ceilings is a specific example. It demonstrates the NEC commitment to preventing electrical fires. By addressing potential hazards proactively, the code helps to protect lives and property. The NEC is a dynamic document. It is updated regularly to reflect advancements in technology. It also incorporates new safety concerns. Staying current with the latest edition of the NEC is essential for all electrical professionals. Continuing education courses and industry publications can help electricians stay informed. They can also keep up to date with code changes. The NEC is a valuable resource for electrical professionals. It provides guidance on the safe and compliant installation of electrical systems. By following the NEC requirements, electricians contribute to electrical safety. They protect people and property from potential harm.